Hi guys, welcome to Tutes Online. Today I'll be talking about basic integration. Integration can be thought of as the opposite of differentiation. So differentiation is similar to minusing and integration is similar to adding. And integration can be used for many things, one of which is to find the area under a curve. So that means if we had our axes and we had some sort of curve, we would be able to find the area underneath this curve. Now one way to do this would be to add up a whole bunch of rectangles. So if we had a rectangle like that, and then we made a rectangle like that, another one like that, all of these rectangles to approximate the area. You can see that we'd be correct in adding up all these areas, except there's a little bit of spillover over here. So there's a tiny bit of error. And you can see also that if we made these rectangles even smaller, so if they were here, there would be only a tiny bit of error. So this width here, if we can make this really small so it approaches 0, then our error in our approximation of the area will approach 0. Now there's two types of integration we'll consider. There is definite and there's indefinite. So for definite integrals, you'll only be looking at a certain region. So there might be this little region here between 1 and 2. Whereas for indefinite, you're not looking at these intervals, you're just finding a general equation without substituting these interval values. So if we looked at a curve like y equals x, which is just a straight line like that, where this is y equals x, this is our y-axis, and this is our x. We could choose an interval, so if we chose from 0 to 5, you can see we've formed a kind of triangle. So we can find the area under this curve here. But we know that for a right-angled triangle, the area would be equal to our x times by our y, which is our width there, times by the height, times by a half. Or in this case, because it's 45 degrees, it would just be x times by x times by 1 over 2, which is 25 divided by 2, which is 12.5. But we can solve this using integration. To integrate, we would write the integral, where this symbol is known as the integral, and it looks a bit like an S, which is sort of short for sum, because we're summing up all those rectangles. We're integrating our shape, which is y equals x, which is x there, and we're integrating this with respect to just the x-axis, so that's the only axis we're interested in. So we'd say dx, where d is similar to the delta x, but it's approaching 0. And we have an interval, so we have two values. So we're integrating from the 0 to the 5, and so that's how we'd write out our integral equation. But how do you actually integrate something? Well, you might remember that I said that integration is the opposite of differentiation. So if you look at the differentiation of x squared, for example, what we do is we bring it down to the front, our index, and then we minus 1 from it. So we've got our 2 out the front, times by x to the power of 2 minus 1, which is 1, so that's just 2x. But for integration, we do the opposite way. So if you started with 2x and you want to integrate that with respect to x, what you do is you add 1 to the index, so that's 2 times by x to the power of 1 plus 1, so that's 2, and divided by our new index, which is 2. So that's 2 here. 2's cancel, and you're left with x squared. So you can see that we went back to our original equation. So as a general way of writing it, you could say ax to the n will become ax to the n plus 1 divided by a new index, which is n plus 1. So that's our general rule for how to integrate. So going back to our triangle, to integrate this, we add 1 to the index. The index is currently 1, so we're adding 1 to that. So it's x to the power of 2 divided by a new index, which is 2. And when you're integrating, you also have to add a constant to the end. And I'll explain that a bit later. So you'll have a plus c, our constant. But we have these limits here, the region we're integrating between. So what we do is put a square bracket around the whole thing. And we're saying we're integrating from 5 to 0, or 0 to 5, I should say. So now we substitute our values. Because we're talking about between a and b, the distance between a and b is b minus a. So what we want to do is substitute 5 in. So this is 5 squared over 2 plus c. So you can see I substitute the 5 in the x. Minus a, which is 0. So we've got 0 squared over 2 plus c. So that's 25 over 2 plus c minus 0 plus c. So that's minus c. You can see that the c's cancel in this case, which I'll discuss later. And you're left with the answer of 12.5, which is what we previously got when we calculated the area of a triangle. So if you're solving this problem but you're doing it as an indefinite integral, this is where you leave your answer, because you don't need to substitute these values here. All you need to do is leave it as a general formula, and it's important to include the plus c. And what the c usually is just a value which isn't dependent on x. And that could be an initial value of the system if you're talking about, say, the water in a tank, or the distance from something. Or mathematically, if you like, if you start with the equation 5x plus 1, you know that if you differentiate something and integrate something, you should get back to your original equation. So if we differentiate it, we would get 5 times by x to the 0, which is just 5, plus 0 because 1 is a constant, and if you differentiate a constant, it's 0. So then if we integrate it, 5 times by x to the 0, which is x to the 1, so we just got an x now, and that's it. There's no 1 value, so we don't actually get back to our original equation. And so a bit of information was lost. So we add this plus c, and in this case, the c was a 1. Now another way to think of integration is to add an extra dimension to a system. So if you had just a circle, we know that the area of a circle is pi r squared. If we add another dimension to a circle, we would get to a cylinder. So we try and draw that. We have a cylinder. So this is our y-axis, this is our x. So what we're looking at here is not a area under a curve, which is going from 1D to 2D. We're looking at changing from 2D to 3D. So that's changing area to volume. So if we integrated our area, so we integrate from, say, 0 here, 0 on the y-axis, to our height, and we'll call it h. So that's pi r squared from 0 to h. But we're looking at the y-axis here, not x. So it's not dx, it's dy. And really this here should be r. But we're keeping that as a constant, and that's not actually being integrated here. So if we integrate this, what we're saying is we're integrating from 0 to h of pi r squared, and there's no y value here, so what it really is 1 times by dy. So we're integrating 1, so that would be pi r squared times by integration of 1, that's just y, and we'll put our limits in. from 0 to h, which would be equal to pi r squared times by h minus pi r squared times by 0, which is pi r squared h. And that's the formula for the volume of a cylinder. Now there's a lot of elements which I simplified in this video, but it gives you a brief introduction to the concepts involved in integration. It's important to remember also when you're writing an equation, always include your dy or dx, depending on which value you're integrating. And also whenever you're doing indefinite integrals, you always have to remember to add plus c to the end. Otherwise your answer is technically wrong because you're missing information. That's it from me. If you have any questions, post a comment. Please subscribe and visit the website. Thanks.